Alright, so this is my AngryBirds demo. I'm going to kind of jump into the demo right away and outline some of the high level things, and then I'll kind of walk through the implementation. So I'll start this. Okay, so right off the bat we have our level here. I can use the right key to pan to the stage and the left key to pan back to the slingshot. So I have circle colliders on all of my Angry Birds, and all of the pigs also have a circle collider. I can drag around the pig here in the slingshot. It'll create the arc trail as necessary to kind of accommodate the intensity of the shot that's about to happen. Let's see. So I'll release this, and it follows a flight trail that's very similar to where it was projected to go. And then, so what happened there was the bird hit the target. It kind of broke some stuff down. You can see the pig sustained some damage. It swapped out a sprite. Some of the planks here are a little more damaged. And then once it poofed out, because it idled for too long, the camera system moved me back to the slingshot without me having to do anything. So for this next bird, it's the yellow bird. I'll go into slow motion here. And so I press the space button. You can see it's going faster here. It's got a new animation or new sprite attached to it. It goes past the bounds of the screen, so I have a minimum and a maximum bounds for where the X controller can go, or where the controller can go on the X axis. So it won't let me go way far to the left or too far to the right, so it makes sure to keep me in the action. So for the height as well, I have the bluebird here, so I can demonstrate that effect. So if I start it off, press space, it'll pop into 3. Yeah, so those stone circles are rolling a little bit on that pig card there, and you can see that helmet pig's taking damage. The helmet pig is a lot harder to destroy than any of the other pigs. I do have punch through working for all of the birds, and so they also apply to the pigs. However, the helmet pig can only lose 35% of its damage in a punch through event, so it's a lot more durable actually. It has a higher health as well, so it's just harder to take out in general. I'll try and match that trajectory again. There it is. Got him. One thing you'll notice is the game was won, so all the pigs were destroyed, and I get an output message here. I'll go into that when I get into the kind of the callbacks. So also, I'll press R to reload just to demonstrate one more thing. So when I'm flying through the air, I'll put it way up here, so you can see that it keeps the bird in the view. Obviously, the background is a static image, so I run out of background eventually. So it keeps the bird in view, but also when the bird's flying, I don't have control of moving left to right, so it makes sure it keeps the bird in the action when the bird's crashed. But before it's been taken away, I can move the camera around. So maybe if I kind of spike it right here, it'll stop following it on the crash, but I can still kind of move it towards the action. And then, so as it's going back, I lose control again until it stops. This is really a design choice. I do have, I was debating whether or not to allow it to kind of cancel that movement back and just let the player move back as they wish, but I decided ultimately on taking away the control until it's moved back. So I can press the 2 key to go to the next level. So here I have level 19. I swapped out that middle pig for a helmet pig just to give it a little more variety. Let's see, I will shoot the bluebird here, and I can take out quite a few of those. You can see they all sustain damage, and swap out the sprites based on their damage level. I have the big red bird. This one has a little more punch through. Yep, so I took those right out. And then this is a new one. We have the black bird that explodes. So, yep, hit that one right there. Really launched some stuff. And you can see it sustained even more damage around everything. And then, let's see, I would probably want to go a little lower here. A little too low. Okay, reloaded my sling, but a little higher this time. There it is. I'll scroll down. I got that output message again, so that functions properly. So I press 3 to go to the third scene here, and I've got my Ferris wheel working. It's using revolute joints, and so the center, they're all kind of pinned by using revolute joints, and they have a motor function to kind of send them in a circle. The pins between the platforms and the spokes is also a revolute joint, but those also have a gear joint on them to keep them level and to also keep them from kind of spinning around willy-nilly. So it lets the pig stay on there. Also, so we've got a yellow bird again. So this I can show the punch-through effect really well on. So if I go through here, you can see it broke through both of those, and then it slowed down a little bit each time, but it was able to continue moving through without being stopped. So I've got another bluebird. I'm actually going to spike this one so I can show some of the newer ones. Did some damage anyways. And okay, got the blackbird. I'm going to explode him. Okay. So here I have another new bird. It's the green bird for the boomerang effect. So if I start shooting it way high here and I press space, it starts to spin, it changes the sprite, and then it circles back. You can see it has that nice arc pattern to it. I didn't take anything out, unfortunately, but I was still able to at least kind of demonstrate that it functioned there. And then lastly, we have the white bird, and I'm going to go into slow motion mode here using the O key to kind of show exactly what's going on here. So we're flying. If I press space, it drops the egg and it starts to send that off. And then, so once it kind of takes a moment here, it'll go back. So just to kind of show kind of in more detail what's going on here, it's a little subtle, but you can see kind of around here, the arc kind of kicks back up. So this is where we dropped the egg. So it sends a force going upwards and kind of starts to rotate it a little bit, while it also drops the egg. So it gives it a nice kind of Newton's law effect there. And that egg, when it hit the ground, it exploded and caused a little bit of explosion damage going around. Also, if I hit the home key, which for me is function and back arrow, I totally reset the level. So I essentially reload it. So, maybe if I wanted another shot at him, oh, there it goes. Took out the king pig there. Then I'm good to go. So, let me just check my list. All right. So, also something I just want to demo quickly is if I click around the slingshot, obviously I clicked into the slingshot territory there, but if I click around it, it won't notice that I'm kind of going for the sling. But if I click near it, it'll register that I was near enough to actually start dragging it, which I just did there. And then I also have a fourth level. Just wanted to show off that I have the circle colliders working on some of the actual construction objects. So I have a little bit of a remake of the first level. So you can see that they're kind of spinning around, and that's all working properly. Okay, so I'm going to start to dive into the actual design here. So I'll start off kind of at a high level with the bird management system. So the bird management system is kind of at a high level the logic control for a level. So what you can do is when a bird's released from the slingshot, it's responsible for saying, "Oh, camera, you start following it." It's responsible for attaching a crash event callback to the bird that was just released from the slingshot. So when the bird crashes, the bird manager is able to handle that properly and start setting off a new array of events to monitor the bird for being idle, and to stop, making sure that it's facing forward in its arc trajectory. Actually, which I will show that one more time. So if I kind of start off the bird going up, you can see the bird is always facing the direction it's moving towards. And then when I hit the ground, you see it's able to freely rotate, and it also stops tracking it with the trail puffs. So to kind of get a little bit more into this, so the slingshot itself, which I'll briefly go into this, we have this slingshot object here. So when you load a when you load a bird into the sling and then release it, you run this release sling method here, and what that does is it releases the sling from the sling band, which is actually the I'll hide this. So the sling band here is actually responsible for calculating the force, because it also needs to recalculate itself and its angle. So that's responsible for calculating the force in the slingshot projection puff trail. That kind of gives you a preview of where you're going to fly. But once you release it, you get the bird that was just released, and then you execute all of the callback events that are attached to the sling, and you pass along the bird. And this is pretty powerful, because now when you release it, you can say, this is the bird that's flying in the air currently. So that's pretty helpful for us, because when I report a release, I can tell the camera set to start tracking that bird, and I can say, make sure that it clears up the last trail that was in the sky, and I can also attach the crash event on it. Also, I can say, oh hey, you can press space now to activate the bird's special power. I can do that all through this crash event reporting, or sorry, not this slingshot release event reporting. So once the bird crashes, it stops the puff trail. It stops making sure that it's kind of facing the right way all the time, and then it also goes and stops the camera from following it. So that's actually what I'm going to get into next here, which is the camera system. So something I demoed in the Lunar Lander project was a camera follower that always made sure that it kept the landing pad and the lander in view. So what I did was I kind of built on that, and I have this camera set here. I'll zoom out so I can get the whole thing in. Oh, hello. Goodness gracious. There it is. Okay, so I have these dummy targets that I can put on the screen so that it always makes sure that you have the ground in view and up to a certain point in the sky, so it's not going to zoom right in on the bird. So what I was able to create was a bit of a dolly system. So when you say to start tracking a target, the two objects, it'll start actually matching the X position of that bird, so it'll follow it through the scene. But also what it will do is it allows it, since now we have technically 3 targets moving around, if I shoot it way above, it's going to make sure that the ground is in view, the bird is in view, and the middle dolly, or the sky dolly right now, that's going to act as the don't go smaller than this scale. So I also have an event attached to it, which is on AngryBirds Dolly Complete. So when it does that kind of dolly action, where once I crash, when it starts to move back to the slingshot, it's going to disable any control. Well, it actually doesn't itself disable the control. Actually, yes, it does, because I have a try panning effect, so I can enable and disable the ability to move those objects to the left and the right using an input controller, which I'll go over in a minute. But once that's that dolly action is complete, it sends out an event which we use on the bird management to let it know, hey, you can put another bird in the sling, you can enable the sling, you can fire off again, all of that good stuff. So I'll stop the process, and then from there I will go into the input management. So what we have here is we have an input manager, and it updates a list of input controllers every frame. So I went with this input controller method, so I didn't have to have one big globbed file with a million different inputs in it that I have to open up every time I wanted to make a new thing or a new kind of keyboard functionality. So what this allows me to do is I can dynamically, enable and disable different controls at runtime, which is pretty powerful because you can have things like a level selector, which is active at all times, but then you can have also things like the slingshot controller, which you can enable and disable at will. So when you release, you can disable the slingshot until, maybe it's the dolly's gone back again, and then it reloads, and then it says, all right, now you can shoot off. And then you can have things like the Angry Bird controller, which controls the power use. So you can press the spacebar to use the power. And also the level panning, and also, the reload slingshot controller. So using those, you're able to kind of enable and disable functionality on the fly. It's super powerful that way. One thing that I kind of touched on is in the output, when a level was complete, it's not in this log, but when a level was complete, you get the output that says, oh hey, all the pigs have been destroyed, you win the level. So this pig manager here, it's responsible for actually creating the pigs, but to actually create a pig, it goes through the pig factory, which is where the real creation happens. However, when you create a pig through the manager, what it does is it attaches a onPig destroy event, which I have an implementation for the pig manager specifically here. And you can add as many events to a pig game object as you want. This just happens to be the only one I really needed for the purpose. So when a pig is destroyed, it fires off this callback, and it says to the pig manager, the pig was destroyed. And so that pig manager monitors how many it's created and how many it's reclaimed. So when all of the pigs have been destroyed, it sends out a all pigs destroyed event, which I have just a simple implementation here that just prints out on the screen that all the pigs have been destroyed. In a setting where we had our own GUI, we could send off a alert to say, oh, once the action settled, start the game over GUI kind of, and show them that whether they won or lost or what have you. So that kind of covers that. So for the scenes themselves, so what I could have done was I could have constructed each one by hand within a scene in itself. So as far as like the towers go and like this little car here, however, what you'll also notice is in level 3 I have that same car again, and so I didn't. Oh, and level 4 also has it as well. So I didn't go through and by hand recreate it every time. What I decided to do instead was I have a tower system. So I have something called Angry Tower, and what each object that implements it does is essentially it acts as kind of a modular component of a game world that you can kind of copy and paste all over the place. So if I really wanted to get modular with this, like really modular, if I was making a lot of levels, for instance on level 2, we see that we have kind of like 2 towers like this and there's a plank in between them. So what I could have done is, if these were actually like exactly the same, I could have kind of copied and pasted one on the left, one on the right, and then just made a new plank in between, and that would really extend the power. But what I was able to do, at least in this demo, was able to pick up and put down things like that little pig car right there. So that made everything a lot more flexible and easy to use, and it really cleaned up the scenes, which I will jump into right now. So to manage all of the scenes together, I used a state pattern. So the state context, when you set the state, you set an enum value, which is just the enumeration tied to a specific state. So it selects the proper scene state based on that input value. Each state has a draw, load, and unload, and update method, so it kind of mirrors the game workflow. And each level has its own file. So from there, what you'll also notice is the the puff trails here. They use an object pool just to keep things efficient, so we don't have to constantly create new objects. So in my object pool system, I have kind of my managed pool. It uses the pool stack and pool nodes. I have an implementation for the flight puffs, and the slingshot projection, which is the like it does the physics calculation so you can see where it's going to go. And then I also have the puff dispenser to show where the bird's been as it's flying. So let's talk about the visitor pattern here, because this was really kind of the core functionality of what really makes the game tick behind the background. So we use the visitor pattern for collision effects and tracking collisions, but to really kind of fire off those visitors, we use the collision listener. And this is an override of the B2 contact listener. So it has the begin, end, pre-solve, and post-solve methods for different stages in the contact system. So if I kind of dive in here, what I noticed was things like the explosions, those use sensors, so those only work in the begin contact. However, things like punch through only work in pre-solve. So obviously, we have to, once again, things like impulse are only shown in the post-solve. So we have different stages here, and for a long time, it was fine just calling the visitor pattern as it was, just because you're able to know that, if it didn't have the impulse, then you couldn't have been in post-solve, so you had to have been in begin contact. And, I wasn't really using the pre-solve or the end contact at the time, so that worked. However, what I found was the explosions, those can only be registered in the begin contact, and the punch through only works in the pre-solve. So both of these only send the B2 contact across, so I didn't have any way of knowing for sure what was going on, or when in the process it was solving a collision. So what I did was I created a enum type of collision phase, and so I can send across exactly when it's happening. So on a higher level, so we have birds. Each bird has its own type. We have blocks. Each block has its own class, and then same with the pigs. There's pig game object, but you also have each pig has its own class. So there's a lot of classes to have to try and cover with the visitor pattern. So what I did to simplify it was I made base classes, and these actually handle the collisions, or just the visitor pattern part of the collision. And then if I need to get more nitty and gritty, I can. So for instance, a bird is able to smash through a angry block. So what I can do is in the collision listener, when I do the pre-solve, I send through that, it was in the pre-solve stage. So what it'll do, if I go back to my visitor pattern, it'll send it through to this collision action here. So jumping into the code. So this is a lot of contact pairs, but this is to kind of help settle the solution of the visitor pattern, because we don't know exactly who's colliding with who. Sometimes a pair could be swapped. So this kind of helps put all the code in one place for how to actually deal with two collisions. So if I go, for instance, between this contact between the bird and a block, so we can see here that it says, if this is pre-solve, we're going to try to do a punch through. So since I said, I only have these three things, how can I know if it's a yellow bird punching through a wood block? So what I did was, obviously, this try punch through, it'll work down to the actual type almost for free. So it'll have this try punch through method on the bird category class, and the yellow bird, for instance, implements this method. So what I do is I make sure that I have punch through remaining, and I have a block type enum attached to each of the block type, or each of the blocks. So, if it was a wood block, a glass block, or a stone block. So I'm able to really quickly compare what the object category is that I'm colliding with. And so if it's a wood block, then we can go forward and we can do smash through or the punch through. But I also put in place that there has to be a minimum force, so it doesn't do weird stuff like just barely roll into a wood block and have it destroy it. So that's kind of how I deal with the punch through mechanisms here, and that same punch through mechanism also applies to the pigs, except for the hard hat pig, which you can only deal 35% damage at max using the punch through mechanism. It has to be regular damage outside of that, just to really make sure it's making it harder to destroy. So let me just go through here. Let's see. So I think that's really kind of the main gist of how everything kind of works together. There are two features that I wasn't able to get to. The sound is not functional in here. I wasn't able to get to that. In the visualizer, I also was not able to have working in time. So those are the two things that are kind of left out of this demo. However, everything else should be fully functional. So, yeah, that's about it. Thank you so much.